Chapter 3, Section 5 is about proportions and similar figures. So a couple vocab words. The word similar figures are figures that have the same shape, but not necessarily the same size. A scale is a ratio of distance in a drawing to the corresponding actual distance. A scale factor is a ratio of the dimensions of the new image to the dimensions in the original figure. And a dilation is a transformation in which a figure and its image are similar. So by the end of this lesson, you should be able to find the missing measurements of similar figures, and you should be able to use similar figures when measuring indirectly. So in this diagram over on the left, triangle ABC and triangle FGH are similar. Similar figures have the same shape, they're both triangles, but not the same size. The figure, or the symbol with the squiggle there, that means that they are similar. So in similar triangles, the corresponding angles are congruent and the corresponding sides are in proportion. So like whatever this angle measure here is, angle A, it's exactly the same as in angle F. And angle B is the same measure as angle G, and C is the same as angle H. And you'll talk more about that stuff when you get into geometry next year. But for right now, we're going to focus on the sides. So when they say the side lengths are proportionate, that means if I take this distance, like A to B, and divide by F to G, that's 8 over 12. That's exactly the same thing as from A to C, which is 10, divided by F to H, which is 15, which is exactly the same as from B to C and G to H, which is 12/18. And if you simplify each one of these, you end up with 2/3. They're all equal. So that means that all of the sides are in proportion. So we're going to use that to solve some problems. So it says that in triangle ABC and triangle DEF are similar. Remember, this means similar to. We need to find the length of DE. So based on what we just did, we know that the sides are proportionate. So we know that the distance from CB divided by FE has to be equal to AB and whatever this is here. So let's set up a proportion. Remember, proportions are just ratios that are equal to each other. So if we have triangle ABC, we want to divide it by triangle DEF. We got to keep it consistent. So triangle ABC, a length is 32 centimeters, and since that's what was on the bottom, we want to do what's on the bottom of triangle DEF, which is 24, and that has to equal the sides. So remember, triangle ABC is on the top, so that's 27, divided by what we don't know, so let's make it x. And then just like we did yesterday, we can solve by using cross products. So you multiply 32 and x together, we get 32x. And if you multiply 24 times 27, you end up with 648. And then all we have to do is divide both sides by 32, and we end up with 20.25. So that's the length here. And make sure this makes sense. Triangle ABC is obviously bigger than triangle DEF. So this number here should be smaller than the 27, and it is. So then they tell us one more piece of information. They tell us that the distance from A to C over here is 14, and this time we need to find D to F. So we can do the same thing. We can set up the same kind of proportion. Let's talk about triangle ABC first, divided by triangle DEF. So we need 14, is the side here, has to be proportional to triangle DEF right there, the matching side. And then we could take any of the other information. I'm going to take what they gave us, this 32 and this 24. So remember, we want to make sure that triangle ABC's stuff stays on the top. So 32 is going to go on the top, and 24 is going to go on the bottom. And again, just like the last time, all we're going to do is cross multiply. So 14 times 24 is 336. and that's going to equal x times 32. And if we divide both sides by 32, we end up with 10.5. So this triangle over here is 10.5. So a dilation is a transformation in which a figure and its image are similar. The ratio of the dimensions to the new image is called a scale factor. To find the image of a figure in a coordinate plane with the origin as the center, you multiply the x and y coordinates by the scale factor. Now when you get into geometry, things will get a little harder, but for all of these, the origin is the center of dilation. So all we need to do is multiply the x and y's by the scale factor. So if we do this problem, triangle MNP has vertices at 3, -2, so let's draw that in, over 3, down 2. There's M. 3, 5, 1, 2, 3, up 5 is N. And then P is -4, -1. So this is my original shape here, this triangle. Tells us to graph the triangle and its image after a dilation with a scale factor of 2. So that scale factor of 2 part basically means that I want to make this triangle twice as big. So in order to do that, I'm going to take each coordinate and I'm going to multiply it by 2. And you multiply the first part by 2 and the second part by 2. So remember back from 8th grade, when you make a new image, you have the little thing up here. It's called a prime. M prime means that's your new M. So multiply 3 times 2 and multiply -2 times 2. So my new M is going to be over 6 this time and down -4. So there's M prime. Do the same thing with the next one. N was at 3, 5. So if I make it twice as big, I get N prime, which is 6, 10. So over 6, up 10 this time. And then do the same thing with P. P was at -4, -1. So P prime would be at -8, -2. So back 8, down 2, I get P prime. So if I connect this, I get this new triangle here. And if I were to find the area of this yellow one, and find the area of this green one, the green one would be twice as large as the yellow one. So we made it twice as big. Your scale factor can be anything. If your scale factor was like 1/2, you would make a smaller triangle, and it would be somewhere in here, and it would only be half the area. You could have a scale factor of 25, and it would blow it up to be huge. But whatever you do, all you have to do is multiply both the x and the y of your point, and you get your new point. So indirect measurements and scale drawings. So if a tree casts a shadow that's 7.5 feet long, we have it labeled down here, a woman is 5 feet tall and casts a shadow of 3 feet long. The triangles shown for the tree and its shadow are similar to the woman and her shadow. How tall is the tree? So basically what happens in this problem is we have the sunshine. And the sunshine is up here and it hits both the tree and the human. And because of that, it casts this shadow. That makes this angle right here in the triangles exactly equal, because we're assuming that they stand straight up and down. And the sun is coming down, shining this light, casting both of these shadows. So basically, we have two similar triangles. We have one that's 5 and 3, and one that's 7.5, and we don't know. So just like we did with the very first problems, we can set up a proportion. That we have the human one, and then the tree. So the human one is, we can do the person divided by the shadow. So object divided by shadow has to equal the object, which is the tree, that's what we don't know, divided by the shadow, which is 7.5. And just so you know, you could set these up a million different ways. You could do human divided by tree and do like original object and then shadow. So your proportion would look like the human is 5, the tree we don't know, the human shadow is 3, and the tree shadow is 7.5. This right here gives you exactly the same thing as this right here. So it just depends on what makes sense to you, as long as you keep everything in order. But then once your proportion is set up, all you got to do is cross multiply. So 5 times 7.5 gives you 37.5. And 3 times x gives you 3x. And if you divide by 3, you end up with 12.5 feet. Now just like the last one, make sure your answer makes sense. Does it make sense that a tree is a little over 12 feet tall? Yes, it definitely does. The tree should be bigger than the human at 5 foot tall. So all of our numbers lead to the fact that this is probably a very viable answer. And then remember, you can always plug it back in and check it. But if you set up your proportion incorrectly, your answer still might not be right. So make sure it makes sense with the problem. So last part. We have this map here, and we have a ruler lined up with the map. And it says the scale of the map is 1 inch equals 10 miles. So from here to here is really 1 mile in real life. From here to here is really 1 mile. Approximately how far is it from Valkyria to Wasabo? So let's take a look at where those are. Wasabo's right here, and Valkyria is way up here. So let's measure this. This is 1.5 is here, so then we have 3/4. So this is 1.75 inches. And if I know 1 inch is approximately 10 miles, this is my scale factor right here. And I can use this as an equation. And we can think about doing this just like we did the dimensional analysis. I want stuff to cross off. Inches on bottom, I'd want 10 miles on top. So we cross this off. All I got to do is multiply 1.7 times 10, and I get 17.5 miles. Now I know this is obviously an easy conversion, but not all of them will be as easy, so that's why this dimensional analysis thing really helps. Save this one and do it on your own. So in your addition to proving it, can you find the missing measures of these similar figures? And then you need to figure out how tall the tree is and how tall the cat is, and then go back and do this problem here. Make sure you write down any questions you have, and we can go over it tomorrow in class. Have a good night.